Good morning, everybody. Let's start today's lecture. I am sorry we are late, half an hour. So I will continue without giving a break. And I think we will be done around like 10 minutes later than the usual. So we started talking about structures and classes, and structures is something that we knew before, and we said that structures are grouping of related data. Okay, we know this from our C course. Okay, and grouping is very useful because if we have a grouping of data, related data,
Hocam sesiniz gelmiyor, konuşuyorsunuz.
Okay, sorry. So we started talking about structures and classes, and we said that structures are our second aggregate data type after the arrays. By aggregate we mean grouping of related data. If you group related data, then you may have arrays of that data. You may send that related data to functions and etc. It has many useful features, and we all know this from our C course, and we talked about this, and I'm not going to repeat them. After that, we said that the fundamental mechanism of object-oriented programming, fundamental concept of object-oriented programming classes are kind of generalization of structures, actually. I mean, in structures, you have only data, related data. With the classes, it is the same. You add more stuff like functions that work on that data. Okay? Functions that work on data. So that's the idea of classes. Related data plus the functions that work on that data. In fact, in object-oriented programming, they say that do not write any global functions. Only write functions that belong to classes or structures like that. Okay, so if you are writing a function, it shouldn't be a global function. It should be part of a class. Okay, it should be part of a class. Of course, the only exception could be the main function, because main function in C++ is not part of any class. Okay, so we have seen one example. Let me show you the program again. It's like a struct definition. We say that, remember what I said, let's ignore this public for a moment. Okay, let's ignore this public for a moment. We are gonna see what it means later. Okay, I have two integers inside my class. Okay, I'm calling it class now, and I have a function that work on these two variables. Okay, this is how you make a declaration of a class object. Okay, this is exactly, I mean, forgive me repeating this over and over and over and again, but it's important. This is exactly saying integer ij. Okay, what kind of j is this, comma? Let me make this comma. Yeah, okay, integer okay, I am going to make it ik. Okay, so I have two integers, I and k, and I don't know their initial values. They are there, but I don't know. So on top of that, I have two objects. Their names are birthday. Okay, here is birthday, and here is today. Okay, initially I don't know their month and day values. Let me erase them now. Okay, initially I don't know these values. They are all question mark. Okay, and then I start executing my program. I say that enter today's date. First enter today month. Where is today month? Today is here, and month is just next to it. Okay, so today month is going to go there. the user enters, for example, the user enters 10, and user enters, today's day is 27, I guess, 27. Okay, so it is more data now. Okay, and I do the same thing for the birthday, and birthday is there. I entered, let's say, birthday is month 2nd and 15th, February 15th, for example. Okay, so when I executed line 22 and line 24, I got these, and then I call this function output on today and on birthday. Okay, so the function output is not a global function. You cannot call that function. You cannot call that function by doing this output. If you write this, okay, the compiler will give you error message. The compiler will tell you that there is no function named output, global function named output. Okay, if you are going to call a function named output, then you need an object of class day of year. Okay, day of year. I have 2 day of year objects. Okay, so output can work only on the objects of that class, and I have 2 objects of it, today and birthday. I called output on today, and I called output on birthday. Okay, and let me show you the output actually. Okay, enters today date, it is 10/15. Enters month as a number 2/21. Okay, this is the today dot output. Okay, and this is the birthday dot output. Okay, so those are the outputs. So as you see, I do not pass any arguments to these functions. Okay, where does it get the information? Where does it get the information? It gets the information from the object itself, because this is my object, remember? This is my object. When I say today, it has some memory location in the memory, and inside it there is month field and there is day field. Okay? And as always, like the structs, I can use the dot operator to access the members of the objects or the variables. Okay. I guess I have a question. How should we create a function which gives us today birthday? Today, is that today minus birthday? What is today birthday? Give us today minus. You are saying that. Okay. You want to do. So Gökbey, you want to do this? Okay, that's a good question. That's a good question. He wants to do something like there is today minus birthday days before my birthday. This is something that you like to do. Okay, so he wants this minus operator to work on the objects of day of year class. Yeah, we are gonna do that, but you have to wait a little bit. You have to wait a little bit. Okay, so it shouldn't be a global, no, because this minus works on the objects of day of year class. Okay, so all the data it needs are already in these objects. Okay, in these objects. Related to that question, maybe I can do this. It would have been better. Instead of okay. Instead of writing this line, I don't like this line. Okay. Instead of writing this line comparing both months and the day fields of the two objects, I could have done this. If today dot equals, okay, I like to see if 2 days are equal. If today is equal to birthday, then do this, else do that. Okay, so this is some function that I like to write maybe, and that would be very nice actually. I mean, you don't have to go to the inside of the objects and pick those months and day fields and try to compare them, because this equals is smart enough to make that comparison. And of course this equals should be part of the class itself. So this equal, okay, I'm going to write it here. The function equal, what should it return? Output returns void, but the function equals, or was it equal or equals? I think it was equals. What should it return?
Boolean.
It should return a Boolean, yes. It should return a Boolean, but it needs a parameter. Why? Because I have to compare my month and day with somebody else's month and day. So it's going to take another day of year object. Okay, it will take another day of year object. So, well, I mean, the fact that the output didn't take any parameters doesn't mean that your functions cannot take any parameters. They can take parameters, of course. Okay, so if I had such a function in my class definition, then I could have written this if statement between line 30 and 31. Okay, so maybe we are going to implement it later. Okay, so let's go back and let's look at the implementation of the output function. As always, we don't implement our functions when we declare them. Okay, we declare them later. Okay, this is our class declaration. Inside the class declaration, I have our function declarations and the variable declarations. I did that. Let's implement this function output. This one says that output is not a global function. Okay, this is a binary scope resolution operator. We have seen this before. When you implement your function, output, you need to put the class name first and scope resolution operator and the name of the function. Of course, you need to tell the compiler what it returns. In this case, our function did not take any parameters. So let's start coding. The first statement is a switch statement. It says that I am going to look at the month. If month is 1, then I am going to write January. If month is 2, then I am going to write February, right? So this is a simple switch statement. Of course, we don't forget about the breaks. Good. So last time I asked you this question, where does month come from? I mean, month is not a global variable. Month, we did not pass it with the parameter of the function. Where does it come? Remember, to answer to this question is from here. Line 26, this is how you call function output. Output is not a global function. It's a member function of this class. To be able to call this function, you need an object of that class. And today is the object in this case. If you call output on today, you're calling output on this object, okay? When you call the output on this object, month is here and day is here, okay? So the one feature of this object-oriented programming is you can be almost certain that it is always certain that the number of parameters to your member functions will be much smaller than the number of parameters of your C functions, because with the C functions you have to pass all the parameters to the functions, all the required information if you are not using globals, and we told you that globals are not good. So if you are not using globals, then that means that in C you have to pass all the required data to your functions. But with object-oriented programming, since you're calling your member functions on objects, okay, your parameters are not needed. I know that all the data that I need is within the object. That's why we say that we put together all the related data in a single capsule, in a single structure, in a single class. Okay, so that's the implementation of day of year, and month is there, and the end of switch statement is here. There is a nice error statement saying that, I mean, no, I cannot have a month of 15. Okay. If the user enters -5, the user might enter, if the user might enter as a day, okay, -5, then this output function will tell me that there is an error. And at the end, I print out the day field or day data member. Okay, that's the whole program. That's the whole program. Oh, let's implement this in this part. Let me implement the equals function. Let me implement the equals function. I know that the equals will return Boolean. Of course, day of year is here, and it will take another day of year object. And usually with this kind of situation, I say that other. I took the other. Okay, so I will return if my month is equal to other's month, and if my month is not, and if my day is same as the other's date. So I will do this. Return month is equal to other dot month, and day is equal to other dot day. This is the implementation of day of year. Oh, nobody's telling me. You are making a very bad. Okay, what is the big mistake here? I made a very bad mistake here. I forgot to put the name of the function, right? I mean, this is just name of the class, and I forgot to put the name of the function. So let me make this a little bit smaller so that I can fit in the name, day of year, okay, dot equals. Okay, so this dot didn't look nice. Let me make it nicer. Scope resolution operator. Okay. Okay, so equals function is like declared like the output function. We are saying that I am not implementing a global function. The function that I'm implementing is part of this day of year class, and it returns a Boolean, and it takes another day of year object. By the way, this day of year, what do you think the size of, remember the size of operator? Size of operator. What would size of day of year return? Guess, take a guess. What is size of day of year? Yunus Emre, 8 byte is a guess, but good guess, but what is What is 8? What is 8? 8 is, yeah, yes. 2 times 2 integers, yes. Yeah. Only member variables, maybe. Yep, that's true. So maybe these people knew about object-oriented programming. Maybe just they guessed it. Okay. Size of this class objects are just 2 times. Okay, let's say this is 4 bytes. This is 4 bytes. Okay. It will be just 8 bytes. You're gonna say, how about this function? Function is not part of the class? Yeah, it's part of the class, but functions are not repeated for each object, right? So for each object you have the member data. You don't have the functions. Okay, functions are just, there is one function for the whole class, but for each object of the class you have to repeat these data members. Okay, you have to repeat this data members. Okay, so back to this function. Since this object is 8 bytes, it is large, right? It is large, and I don't want to do this call by value thing because it is copying the whole thing. Okay, it is copying the whole thing. So what do? I do this. I say that I am going to pass this using a reference, but if I pass this using a reference, there is this risk of modifying the objects within the function. So maybe I should put a const at the beginning. So usually, almost always, not usually, almost always, you pass your objects to functions using constant references if you're not going to modify them. Okay, good. Any questions? Okay, so object-oriented programming, the basic of the fundamental mechanism of object-oriented programming is the class. Okay, class says that I will aggregate all the related data, plus I will put in all the related functions in the same structure, and I will call it class. And the task of an object-oriented programmer or the object-oriented programming language designer is to find or design nice classes with these data members and the functions to work on them without writing any global functions. Everything has to be global. Okay? So that's the rule of the object-oriented programming. Of course, C says that C is an object-oriented programming language, but C is an object-oriented programming language, but C++ is also continuation of C, right? It has to behave like C. So unfortunately, C++ cannot keep this promise. Well, at least we know that we have to write this main function, right? This is a global function. And from time to time, and unfortunately, we will have to write some global functions just to keep compatibility with C and just to make things a little bit more efficient. Okay, good. So if there are no questions, then I will just continue. Did I miss anything? I think I talked about. Let's go back and let's try to, yeah. So this is our day of year class. There is one function and to this. Okay. Only member function prototypes are there. It is possible to have your implementation in here, but we will leave that to later classes. Okay, my month and day, and then when you declare your objects or your variables. Okay, so when do we call objects? When do we call variable? Okay. Types. We have types like the integer is a type, double is a type, character is a type, etc. These are fundamental types. Classes, okay. The classes, string is a class. Remember, string is a class. Day of year is a class. and many other definitions that we are going to do, they all will be classes. So if you write this new type yourself, is called class, okay? But there are fundamental types that comes from the language itself. Those are called types. So integer is a type, string is a class, okay? When you say integer I, this is the type, this is the variable. When you say string s, this is the class, this is the object, okay? These are parallel things. This is just a terminology, okay? This is just a terminology. So this is a class, this is an object, type, and variable. And sometimes we just use them interchangeably, but usually this is the definition that people use. So I have two objects of the same class, day of year, and I made this declaration, okay? And inside my object, I have my data, I know that, okay? And to access the data members of the objects, I use the dot operator like I did with the structs. To call a function on an object, I use the same notation, dot operator, dot output, and it invokes the member function, or calls the member function. Okay, I think there is a question. Sheval says that, can we use global functions in member functions? Of course you can. Sure, yeah. I mean, Sheval, your functions, your member functions are like regular functions, but they cannot be called as global functions. But inside your member functions, you are free to do anything that you like. You are free to do anything that you like. You may call your cout, cn, stream insertion extraction operators. You may call your printf, scanf, your file open operations, etc. But since we don't like global functions in C++, usually we don't prefer calling global functions. Okay. Good. Anything that I forgot? Yeah, okay, this is how you implement it. Like other function definitions, you may implement them after the main definition, or if you like to have your own separate implementation file, you may put it in there, okay? Day of year may have its own implementation file and the header file, like our functions, right? And in that case, it will be that way, and it will be even nicer. Okay, so usually we don't, as I said, usually we don't include any implementations. From this part to this part, when the customer of this class looks at it, okay, he or she does not see any details of how the things are done. This is called the interface. This is our class interface. If I like to use objects of this class, then I need to read this interface. Okay, then I need to read the interface. Interface is something that you need to know to be able to use the objects of that class. Okay, and interface has to be nice, clean, understandable, and easily usable. And object-oriented programming always tells you to design your interfaces in a clear way. Okay, don't make it complicated. Okay, good. So implementation is hidden after the main function. It's like the idea is the same. You declare your function, you call it, later you implement it. Implementation is kind of hidden. Okay. Good. So we talked about this. Let's continue then if there are no questions. This is the sample output. Okay, and dot and scope resolution operators. We have seen them before, especially the dot operator. Okay, we have seen it. Scope resolution operator, you just separate the class from its function. We have seen it a few minutes ago. And what's the class? I mean, what do you mean by class? I think I try to tell you what it is. Class is a full-fledged type. It's a new type, like an integer or double. Okay, and we can have variables of class, new class, Okay, we call them objects, not variables, but objects. And like we do with the integers or doubles, we may pass them to functions using pass by value or pass by reference. And we may have arrays of it. Okay, how you do the integer a, okay, an integer array of size 10, and this is a day of year array of 10. I have 10 day of year objects now. It is as simple as this. Okay, so wherever you can use an integer, you can use this class. Okay, so with the integers I may have arrays. I may do the pass by reference, pass by value. With the day of year, you may do the same thing. Can use class type like any other type. Okay, so let's look at this important concept of encapsulation. Okay, encapsulation means putting your related data and the operations that work on that data into same capsule. Okay, you encapsulate them, bring them together, all of them, the related data and the functions that work on that data, and that makes an encapsulation. Okay, an example is integer class or integer variable. Inside the integer variable there are 4 bytes, all the data that it needs, and all the operations with the integer data, plus, minus, multiplication, modulo, etc., they are all with this variable. Classes are the same. The only difference is that integer is designed, integer, double, character, float, those kind of classes or variables or types, they are designed by the language designers, and all the required operations are already implemented. With the classes, we do the designing ourselves. Okay, we design the classes and we make decisions on what kind of data should go in there, okay, and what kind of operation should work on that data. Okay, so that's the whole idea, and we call this encapsulation. And encapsulation is one of the main principles of the object-oriented programming, encapsulation. We will always try to put the data and related operations into the same capsule, and we will call it a class. Okay. Another concept with object-oriented programming is abstract data types. Okay, abstract data types. Sometimes it is shortened as ADT, abbreviated as ADT, abstract data type. One abstract data type is integer, another is double, another one is string. Okay, so with the integer and double and string, usually you know what kind of things can work on it, okay, but you don't know the details. Okay, if I didn't ask you, you didn't know how to multiply 2 integers, right? I mean, only a few of you did the integer multiplication, or integer or double multiplication, or how the strings are merged together, and etc. Okay, so those kind of things are abstract things for you. The only thing that you are interested in, okay, is the interface, what you can do with them. You don't care much about how it is done. It is abstracted away. You know there is this data type. You don't know how the things are done, but you know how to use the operations. Okay, so we will try to repeat this as much as possible. Okay, try to write abstract data types that the users know about the interface, but they don't know about the implementation. Okay, often the ADTs are language independent. I mean, the meaning of the string is the same for C++ or Java or C#. Integer or double is the same. Of course, their implementations are different because they are different languages, but the concept of a string is the same with all the languages. Okay, so we talked about the encapsulation, bringing together as one, and we bring together all the data and related operations, and we declare a class, and then we get an object. It's like making a struct definition and making objects of that struct, make a class definition and get the objects of that class. Okay, so object is encapsulation of data values and operations on the data. These two things, data and operations. Object is an encapsulation of it. Okay, let's move on and let's talk more about the basic principles of object-oriented programming. There are a few more principles, but these are the most basic one. Okay, if you are doing object-oriented programming, okay, this is the picture. This is the most important information about object-oriented programming. What do we call an object-oriented programming example? Okay, with the object-oriented programming techniques, okay, what you are doing is you hide information. You hide the details of how operations work, okay, not known to the user of the class. How a string works, how a string, when I say, let's say I have a string, I have two strings, str1 and str2, okay. I don't know how this str1 less than str2 works, but when I make this operator call, it works, okay. So I hid all the information about how this comparison is done. I don't know how well, I have very good guesses. I am a good programmer. I can make a guess, but I don't have to make a guess, okay. All I do is I just use it. And this is called information hiding. Information hiding is a principle for the benefit of the class user, class customer, okay. We are not hiding our information because our information is secret. We are hiding it because that information will not be useful for the user. If the user knows how this operation works, he will not be a better user, okay? If the user knows how this str1 plus assignment str2, okay? If the user knows how this plus assignment works, he will not be a better programmer, okay? That's a detail, okay? If I know how the ignition system, fuel ignition system works on my car, I will not be a good driver, okay? Good driver means that I follow the rules. I always keep my eye on the road. Always be careful. Don't use your cell phone while you are driving, and etc. Good driver doesn't mean that I know how the car engine works or the car electronics works, right? Good user means that I know the interface and I can use the interface. So all the detail information is hidden from me from a car, okay? As a driver of the car, all that complications are not available. They are all hidden. All I know is I have a steering wheel and I have a gas pedal and I have a brake pedal. That's what I know. So when you do the information hiding, you hide unnecessarily detailed information from the user. Unnecessarily detailed information from the user. Data abstraction is something related to information hiding. Okay, details of how the data is manipulated within ADT class not known to user. Okay, so they are very, very related. It is almost the same thing. And encapsulation is another one, bringing together data and operations, but keeping the details hidden. Of course, they are all related to each other. And if you are following these rules, if you are hiding your information, details of how operations work, okay, details of how data is manipulated, and putting together all the data and the operations in the same capsule, They are all three legs of this whole object-oriented programming language philosophy. Okay, so this may seem weird. This may seem too simple to make one important concept like object-oriented programming language. You might wonder, how could this be the best idea of all the programming languages, or one of the best ideas of all the programming languages? But it is. Our experience for the last 40-50 years tells us that if you follow these rules, along with some other rules that we are gonna introduce later, okay, if you follow these rules, you will end up writing reusable code. Okay, if you hide unnecessary information, if you nicely encapsulate, the classes that you are gonna write will be reusable. The classes will be like string-like classes. Okay, string-like classes. You will notice that, okay, I have written such a class before and I can use it over and over again. The nice thing about code reusability is, of course, the code is ready. You don't have to test it. You don't have to debug it. And you know that it works. If there is a bug in it, you fix it and many projects will benefit from it. So code reusability is a very nice property. And object-oriented programming tries to do this using these principles. Okay, so in the rest of the semester, we will design our classes. Okay, we will implement them. And while we are doing it, we will always try to do the information hiding, data abstraction, and encapsulation. Okay, good. Any questions so far? Any questions? So I will go back to, remember I told you that, oh, no, wrong program, sorry. Remember I told you that let's ignore this public keyword for a while. Okay, now we are going to talk about it. What did we say about the information hiding? We said that we hide information from the user if the user doesn't need to know about it. Okay, so object-oriented programming should give us some kind of a mechanism to hide that kind of information. Okay, so to do this, this is what we follow. This is a rule that we follow. The data in our class is always considered as hidden from the user. We don't like to show our data to the user. Okay, the user doesn't need to see our data. So what does the user supposed to what is the user supposed to do then? I mean, if he cannot access the data members, he's supposed to use the functions of the class, not the data. So object-oriented programming says that hide your data from the user, let the user use the functions of the class. This is how we are gonna do our things. And okay, this is one example of doing this idea. We say that day of year includes 2 data members, but they are private. Users of this class, who is the user of this class? Of course, the user of this class is the one, day of year, let's say day 1 and day 2. User of this class is the one that declares these 2 objects, D1 and D2. In this case, I can freely call D1.input. It looks like this function will read some data from the keyboard and will put them in my object. Or then after that, maybe I can do D1.output. These are the only things well, maybe I shouldn't say only things, but these are the some of the things that I can do on my objects of this class. Okay, because these two are public. Public means that it is for open for everybody. It is open for all the. It is open for all the um, all the customers of this class. Whoever declared this D1 and D2, they could use input and output on them. Okay. Private means that customers of this class cannot access these data members. If I, this is of course okay, this is of course okay, but if I do C out D1 dot day, okay, the compiler will tell me that as a customer of this class, you don't have enough privilege to access the day. Sorry. That's a bad mistake. Okay. Okay. You cannot access the day field of this D1 object. Okay, because it is private. This part is public section. This part is public section. And this part is private section. Okay, the red part is private, green part is public. Public section could be used by the customers of this class. Private section cannot be used by the customers. It is hidden. We are trying to follow this information hiding and data abstraction. Okay, details of how the operations work, not known to the user. Details of how the data is manipulated, not known to the user. Okay, the user is not the user should not know about this data, how I use it, if I have them, if I don't have them. The user should not care about them. Okay, this is how you enforce those three principles on your classes. We didn't have this before. Okay, with the structs, with the structures, everything was public. All the data with the structures that you have were public, but with the classes, only the public part is public. The private part is not public. Now data is private and objects have no direct access. Direct access is not possible. All I can do with this class objects is calling input and output. And by the way, this is also possible to D1, D2 is possible, right? And what else? What kind of other operations can I do with the D1 and D2? I can do this too. Day of year DP. Okay. Address of D1. I could do that. Okay. Excuse me, I have to take this. Efendim? Merhaba. Buyurun. Ama o kontak nedeniyle bir madde bulamadık biz. Böyle bir şey yapmıyor. Böyle bir madde kontak nedeniyle bir madde yoktu. O kadar gösterini açıkçası. Bir şeyini de bilemedim yani. 15 metre vazgeçse metre ceza diyeceğini de bilemedim. Yani çok da zor oluyor. Nasıl? Nasıl diyeyim? Özellikle çok ders yapmamız lazım. Ders var, bir ders var. Ve çok ihtiyacı var ama yani çalışmasa ne yapacak? Akşamda bir şey yaramıyor. Ben de böyle yapmıyorum ama. Ben de böyle yapmıyorum. Yani kontak yapmak yapmıyorum. Yani bunu bana göre hiçbir yere yaramıyor. Biz beraber arkadaşlar. Ya orada yazılması tabii ki daha doğru oluyor. Kusura bakmanıza şu anda benim bir toplantım var. Ben sizden haber bekliyorum, olur mu? Tamam. Teşekkür ederim. Excuse me. Sorry, I am back. This is one operation that we can do. Take an address of an object and assign it to an day of year pointer object or variable. Okay, that's the whole thing, really. I mean, that's the whole idea of object-oriented programming. It might come as a surprise to you. That's it. That might be your response. Are we doing this? Yeah, that's what we're doing. We are gonna write these kind of classes. We are gonna make some part private. We are gonna make some parts public, and we will keep writing functions working on these data. That's what we are going to do for the whole semester. Okay. Of course, there will be more details about object-oriented programming, details about C and C++ programming, and these details will take lots of your time. But basically, that's what we are going to do. Okay. I know some people. They do this. Their classes are like class A, some stupid name, and public all the functions f1, f2, and all the data a, double b, and use these objects of this class as a global field and call these functions like on the objects of class A, and all the data are public. This is not object-oriented programming, okay? If you are using the C++ compiler to compile such a code, you are using the C++ compiler as a C compiler. This is not C object-oriented programming, okay? If you are saying that you are doing object-oriented programming, you should follow the rules. Information hiding, okay? Abstraction, encapsulation, okay? If you are not doing this, you are not writing an object-oriented code. Always try to do this: hide information, abstract your data, and encapsulate. Okay? If you don't do that, you are violating some of the object-oriented rules. And in C++, unfortunately, as I said before, we sometimes violate some of these rules, and I will tell you when we do that, and we are going to say that, okay, we are violating it, but what you're going to do? I mean, this is what we have to do now. As long as you know what you are doing, you might be okay. Okay, so same thing that I told you before. Declare day of year today. Object today can only have access to public members. Okay, so this is not allowed and this is not allowed. You don't do that. The two things that you are allowed to do are these two calls, and the others are assignment and the address of operator, and there are a few more things and we will talk about them later. Okay, good. Any questions? No questions, and then that means that I will ask you questions in a few minutes.
Sir, may I ask you something?
Sure.
What about the setters and getters? Are we going to be using those for the encapsulated?
Nobody knows about them yet.
Okay, but they are included in the C++ way of object-oriented programming, right?
Well, nobody knows about them yet. We will talk about them in a few, maybe next lecture. Okay.
Okay.
The setters and getters, just they're simple public functions. Okay, and you are supposed to write them. Okay, you may usually our class structure is like this. You put your public section first, then the private section later. But the order doesn't have to be this way. The order can be mixed, just the reversed. But usually this is in C++. This is how we do. We first show the customer our public place, and for the private, it is not important for them. They are not supposed to read the private part. They are supposed to read the public part only. Okay, so usually we put our public functions at the beginning of the class definition. Okay, and the rule is almost always you make your data private. I am not saying that it is always, but almost always. Okay, and sometimes you may have void, let's say function 2, private functions. Sometimes you may have private functions, and it is not a rare case, and we are going to see some really helpful private functions. This function f2 cannot be called by the customers. Okay, the function f2 cannot be called by the customers. So who's going to call f2? In this case, I cannot do that. d1.f2. I cannot do that. Okay, so who's going to call f2? If I cannot call it, what good is f2? Member functions call them. Yes, exactly. The functions input and output may call, if they like, f2. So f2 is like a helper function, and of course f2, when it is called, it can do anything it wants because it is part of the class. Okay, so we talked about it. Good. Maybe the question that was the previously was asked is how about setters and getters? This is what we do. Maybe I should go to the book and I show you some example from the book. Where is my book? Here is my book. Okay. Open this using this one. Let's open this using the regular viewer. Okay, I think I have my bookmarks. Okay, good. And here, classes. Okay, good. Let me show you this. Okay, this is one good example. There is a class named automobile, Okay. And this automobile has private data members, price and profit. Price is the basic price of the automobile. Okay, profit is your profit when you sell your automobile. This is how much profit you're gonna get. Okay. And as you see, get profit, the one that returns you the profit amount is private. And this is possible, but I am not going to do this yet, but I am going to show you a okay. Okay, this is a day of year class from the book again. A little bit more complicated, more capable day of year class. Public section has 1, 2, 3, 4, 5 functions. Okay. And the private section has 3 characters and a day. It looks like they decided not to use the month as an integer. Instead, first letter, second letter, and third letter of the month. For January, it's going to be J, A, and N, right? It looks like that way. But I'm just guessing it because this is private. For me, the important thing is these, right? There is input, there is output, there is set, there is another set. Okay, we are gonna see them in a few minutes. And there is get month number and there is get day. Okay. So it looks like they didn't give me the implementation. It was just a interface stuff. Okay, let me give you another example here. Okay, another example is here. I have all the implementations. Okay, this is good. Okay, let's look at this implementation or the whole day of year class. This is input, day of year, output. Okay, there is this set function. Set function for the precondition is new month and new day from a possible date. It says that your month and day should be valid numbers. And there is another one, set. So it looks like there are 2 functions named set. Okay, there are 2 functions named set. One of them takes 2 integers, one of them takes 1 integer. It is overloaded and they can work nicely. Okay, and there is get month number and get day, 2 other functions. 2 of them just return integers. One is going to return the month, the other one will return the day. Okay, so this is one nice interface. I did not show you any implementations yet, and I'm going to show you the implementation yet. But before I show you the implementation, I will show you how we used it as a customer. Okay, because this was the interface, all the data, all the details are hidden from me. I don't know how it works, but as a customer, I can use this class objects without any problem. Do I have a question? Bilal has a question. So private part is only for public functions, right? For the private part is only for functions of the class. Yes. Not only for public functions. Private part is only for the functions of the class, because your functions could be public functions or private functions, right? So we wouldn't say public functions, we would say functions of the class. Okay, good. So as a customer of this day of year class, let's use it. Function main. Okay, today and Bach birthday. Remember what did we do previously? We said that C in today dot day, etc. No, we don't do that anymore. We say that there is an input function. Okay, that input function will work on today. After input function works, it looks like today input is going to read some numbers from the keyboard. Then there's an output function. Okay, so I have this birthday here, birthday, and I use this function set. Function set is setting the data members of the class. Say that birthday month will be 3 and day will be 21st. So I modified my object using the public set function. Okay, and I just call this output. So how am I gonna do this comparison thing? I mean, if today is equal to birthday, it's going to be either a function that I have written before equals, or it's going to compare these numbers. Remember, I cannot say today dot month, okay, today dot day, because those are not accessible. So what am I gonna do? I call this get month number. Okay, get month number. I call this get day and get day functions. Those functions will return me my day and my month. And if they are equal, I will say happy birthday. Otherwise, happy on birthday. Okay, so I have this interface. I call those functions, and it looks like I only called the single set function. The set function that takes 2 parameters. I did not call the other one. Okay, so my main function ends here. Let's look at the implementations of these functions. Okay, this is the set function. New month and new day are parameters for the set. First, I make this check if it is greater than 1, less than 12. It's a new month. Then I assign it. See, this is new month. This is month. Month is a data member of this class. Month is a data member of this class. And can I do this? $290. Okay, do it one way. Oops. This is one and this is the other one. So I divide it into 2 so that I can always keep our class definition here. Is this too small? No, sorry, this is too small. I probably will not see it. Anyway, okay. So month and day are privates. So, but set is a member function of the class. That's why I have direct access to month. Okay, so I make this assignment if it is valid. Otherwise, I will say that illegal month value, program aborted. Okay, and this one does the same thing. Okay, check the day. If it is okay, then assign it. Otherwise, terminate the program. This is how set works. Okay, this is how set works. The function set works. Okay, so what else? What can I do with the, okay, this is the other set. Okay, it's the set that takes the, you know what, why don't I open up the code itself and instead of from the book 6.4, right? So I used, what did I use? Okay, this is some kind of editor. Okay, day of year class, right? Get rid of this one. Month and day is here, they are here. And set is there, set is there. So I showed you the comparison and how we did that, and I show you the set. Okay, and this is a set function that sets only the month. It checks the month. If it is okay, it sets it. Otherwise, it just says it's not good. And it looks like when I set the month, I am setting the day to 1. Right? I am setting day to 1. Can somebody give me an idea to write this function set in a much simpler way? I like to write the set in a much simpler way. Instead of writing it in 3, 6, 7, 8 lines, I like to just write it in a single line. I like to write this function in a single line. Get rid of everything, and I will write it in a single line. Just tell me what should I write here. Burak, I don't understand your question. Why are we using stdlib library? Without calling functions, how are you going to write your... Hussein Ömer, no, it's not a good idea. No. That's... Well, I don't like this function. It's because it repeats the same code in here, right? Let me make this a little bit smaller. This part of the code and this part of the code are exactly the same. This is code repetition, copy and paste. Okay? I don't like it. Okay? So how am I gonna get rid of this code repetition? This is what am I gonna do. Just get rid of it. Get rid of it. And I know that there is a nice set function available. Okay? That function takes 2 parameters. One of them is new month, the other one is day. Okay? So I will say new month, comma 1. And that's it. Just a single line of code. So I am calling the other function within this function. Okay? So your answers are, Jakub Talha says that set, okay, he's using the defaults, and I didn't show you the defaults yet about that. We should create check function. Hussein Ömer says you should create check function. Yeah, it could be, but there is a good set doing the check. Anil Emre, that's right. We are using overloading. That's what I said before, yes. This is overloading. There are 2 sets, line number 10 and line number 13. It is using the same name with different parameter numbers. Okay. Enis, why? I don't know what you mean by question mark. Can't we set the day to 1 as default? Yes, you could do that. So people are saying that why don't we do this? Well, since I did not want to, okay, do that, and after doing this, we should be fine. This could be that too. This is another solution. But these two cannot happen. You realize this, right? This code will not compile. This code will not compile because it will tell me that, I mean, when I use set with a single parameter, it will not know which one to call, this one or that one. Okay, so my current solution is only this one now. Okay, so isn't it better to use it this way? What is this way? And is what kind of questions are you asking? I mean, what is this way? Send new month and day? Are you telling me to implement this set function? Oh, you are saying that you put a day in there? Okay, so question. I think I don't know what Enes wants to ask, but I am asking this. What happens if I do this? What happens if I replace line 69 like that? New month, comma day. If the day was not set before, it will not work. Yeah, if the day is not a meaningful thing, it will set the day to that unmeaningful thing again. Or even if it's a meaningful thing, it is not going to change the day from whatever it is to one, right? So it will keep the day, whether it's a junk day or regular day, it will keep the day the same. So this is not a good idea. Okay. So that's good. If the day, so understand what Yeshim says. If the day wasn't set before, it would not work. Well, by would not work, she doesn't mean that it will not compile. She means that logically we will not get the same effect. Okay. So that's a good point that Enis was making, but I think he's okay. So by the way, a question for you. Let's go to main function and let's do this. Today dot output. Okay. What would I get from line 29? Line 29, what would I get? Or 28 rather, 28. Yeah. Hussein says 0. Mohammed Bedri says default value or garbage. It's not default value, it's just garbage. We don't know what will be the values of that today. Remember, inside the today there is month and day. We don't know their values yet because we did not set them. This is same as saying this integer I and cout I. What would this print on the screen? Most of the time 0 maybe, but you're not guaranteed to get 0 all the time. Sometimes you will get garbage because I did not initialize it. This is initialization problem. So this class is not a very nice class because at the beginning we don't know what the values of those month and day for an uninitialized today or Bach birthday. Okay, so good. So let's go to the implementations again. Set works this way. Set get month number is so simple. It just returns the month and it just returns the day. Okay. Input is again says that enter the month as a number, enter day as a month. Okay, enter the day as of the month. I will get both of them. I will do this checking. Month should be valid, and day should be valid. Of course, this one doesn't care about the January, February, and the months that take 30 days or 31 days. It just does it that way. Okay, and there is this. Other than input, there is this output. Output is the same as before. Okay, output is the same as before. Good. So this is a program again that uses this nice simple class and implements everything. And Let's implement our Boolean equals function again. Const day of year and other, right? And where is my this? I'm trying to find the curly brackets. Yeah, okay. I found my curly bracket. I don't know what editor I am using, but what is it? Do you guys know what this is? Do you know? Okay, dev C++. Dev C++. I don't know. I don't remember when I installed this one, but it looks like it's nice. So I am doing is return my, if my day is equal to other.day, and if my month is equal to other.month. Okay, so this is what I return. Hüseyin Ömer, sir, in the month section, why are we using switch case? Can't we use string array? Well, of course you could, yeah. Well, the book does it this way to keep things simple. There could be many other ways of. Hussein says that why don't we have a array of strings and just pick the right index and index into it? Yeah, we could do that. But I think the book did not introduce the strings that truly yet. So maybe they are trying to keep it simple. Okay, so equals is there. So I am going to replace this. If today dot equals, okay, Bah birthday, is it Bah? Okay, Bah birthday, like that. Then it will work this way. Good. Okay, so I showed you everything about this program. Is there anything that I like to? Yeah. Let's talk about this stuff. These two functions are called Mutator functions. These are called Mutator functions, set functions, or sometimes we call them setters. Okay, setters modify the object. Okay, these two functions, they modify the object. They see when I call this set function, they modify the object. They modify that line 56 and 63. They modify the object. They put a new value inside month and day. Okay, since this set, single parameter set, calls the two parameter set here. Okay, both of them are mutator functions. Okay, these two are mutator functions. Okay, these two are not. These are accessory functions. They don't modify anything. They just return you the value of it. Okay, they just return the value of it. They are called accessory functions, or they are called getters. Okay, so usually you write two types of functions: accessory functions or mutator functions. Setters are mutator functions. Okay, getters are accessory functions. Remember that equals function is equals accessor or mutator. Is equals, let's go to the equals function again.
Accessor.
It's an accessor, right? Why? Because equals does not change the value of month or day. By the way, nobody asked me, but without realizing it, I implemented my equals function inside the class. This is possible. This is not a mistake, but I shouldn't have done that way. Let me do this then. Let me take this way out of the class and put it in here and put day of year equals. Yeah. So this is the implementation of equals, and let's get rid of the implementation here. Okay, so equals is a accessor function. Get, month, and get day are accessor functions. Sets are mutator functions. These are getters. Getters are functions that get you the value. Okay, setters are the functions that modify your data, private data. Question for you. Remember what was our principle with the object-oriented programming? Keep your data hidden from the outside world, right? Keep your data hidden from the outside world. That's why I made this month and day private. But I provided two functions to modify this data. Isn't this against the information hiding rule? I mean, somebody can get the values of my month and day, right? They can learn it. It was hidden. And somebody can change their values. Providing setters and getters for my private data is something we do all the time. But isn't this against the rules of object-oriented programming? Hide your information, abstract your data. Can anybody answer this? Use your microphone. I told you that this is important. I told you that principle of, okay, information hiding, details of how operations work are not known to the user, data abstraction, details of how data is manipulated. Okay, so that's why we said that. Okay, that's why we say that hide data from the user. Okay, I made my data private, but later I provided public functions, set and get. My customers can use that set and get to learn my values of month and day, right? And they change their values. Isn't this against the rule of hiding data from the user? Hide data from the user. Yunus Emre, just explain it a little bit more. Just use your microphone. It happens in a way that programmer designed. I did not get it right. I did not get it exactly what you mean. Use your microphone. Or anybody else giving those thumbs ups. Just use your microphones to explain it.
Programmer can block invalid moves, like putting amount 13.
You are saying that I am doing this setting thing in a controlled way. I am not going to allow any invalid dates, right? And I will, since I have the control, I designed the set function myself. I could make this work. Okay, that's exactly right. Providing the set and get doesn't mean that your customers can modify directly this month and day. Let's do it this way. Let's make month string, right? So instead of using integers, I will use strings, such as for January it's going to be January, for February it's going to be February, etc. Right? So how can I make this work with this interface when I say set int new month? Okay, this in this case, if set month is between 1 and 12, then month is not going to be assigned that value. What am I going to do? I think I will do this switch thing, right? I will do something like if month is 1, then if new month is 1, right? If new month is 1, then my month will be what? My month will be January. Else, if you got the idea, right? So even though my set and get works with integers, inside my class I am using strings to represent the months. You may think that this is not necessary, this is not good, this is not a good design, but this is my design. My customer doesn't know that I am using strings to represent the month, right? My customer thinks that all they know is the number of the month and use the integers to set that integer month and get the integer month. Of course, my set and get becomes more complicated, but that's my design decision. Okay, so this is a good design, making my month and day private, and it is up to me what kind of data I use to keep them. It could be either characters, or it could be integers, or it could be, remember what the book did? The book did this before. Where is that? Okay, the book said that I am going to represent the month using just 3 letters: character, Jan, Feb, Mar, etc. Right? So this could happen. Back to my original point, I did not do a bad thing by providing these setters and getters. These are not against the object-oriented programming rules. These are obeying, object-oriented programming rules, because it is up to me how I implement this set and get method. Okay, it is up to me how I implement this set and get method. And sometimes I can even do this. Sometimes I can even do this. See, I moved everything to private part. That means that I am not allowing anybody to set the month and day. Okay, so I have the complete control on my data. So I am hiding my data. Good. Any questions? Any other questions? Okay, let's see. Let's go back to our slides again. Slides from the book. Okay, so we talked about the getters and setters. Getters, they return the values of your data, but your values should not be exactly the same data. For example, in this case, since let me move it back to the original position here. Okay, since my month is string now, my getter for the month, get month number, is going to be complicated. Why? Because it's going to be a switch statement. Switch. No, it's not going to be switch. It's going to be if month is January, then I will return 1. If, again, I admit this is not a good design, but just for the sake of, okay, then I will return to, etc. Okay, see, as you see, I'm just returning an integer, but my get month number is more complicated than just get day. Okay, so setters and getters doesn't have to be very simple. They can be complicated, but nevertheless they are controlling how I use my private data. Okay, setters are examples of mutators, getters are examples of accessors. So the 4 definitions for you: accessor, mutator, getter, and setter. Okay, we try to separate the implementation from the interface. Okay, we try to separate the interface from the implementation. We only show this part to a customer. Okay, the customer just sees this and nothing else. Okay, and in fact this private part, the customer should not read it. The customer is not supposed to read that way. Okay, so it means that I have 1, 2, 3, 4, 5, 6, 7 functions, and customer is free to use any of those 7 functions. And I know that my objects will be nicely built objects because I keep checking the validity of the dates for the set functions for the input and output too. By the way, notice that for the input, where is input? Yeah, input is not good, right? For the input, I think it should have been like this: set. How should I do that then? Okay, integers t1 and t2, right? Get t1, temporaries, these are t2, okay? t2 and set t1 comma t2. Okay, so I am doing the range checking in a correct way. Okay, so this is my interface. When I look at my interface, I don't see any implementations. I am not supposed to look at this private part. I don't know how the data is represented, either using strings or integers or doubles, I don't care. I am the customer. All I know is I read these commands and I make my decisions as customers. Okay, and I write this nice code. I write this nice code. Okay, so I am keeping my interface. Which is this one, from the implementation, which is my interface. Okay, which is line 50 until line 142. Okay, this is the implementation. The customer doesn't have to see this, and customer doesn't see that. Okay, implementation is separated from the interface. The idea of declaring your functions first, then implementing them later, right? It's the same idea. We are hiding information, implementation information from the user. Okay, implementation of a class is hidden. Again, I repeat this over and over again. We are not hiding our implementation because our implementation is secret. We don't say that. We hide our implementation because the user doesn't have to know it. If the user knows about the implementation, it's not going to be useful information for the user, okay? It will make only the user confused. Okay, good. So, any questions? So let's continue and finish up this chapter. I have only a few minutes. Structures versus classes. In C++, usually we don't use structures. Okay, we use classes, but it is good to know the difference. In structures, typically all members are public. Okay, in structures, all members are public. Okay, and usually we don't provide no member functions. We don't provide any member functions in structures. What happens if you provide them in C++? It is okay, but no, we don't do that. Okay, and in classes, typically all data members are almost always, all data members are private, and interface member functions are public. That doesn't mean that all the functions are public. Some of them are public, and we call them interface member functions. But they are technically the same. They are technically the same. By the way, if you don't write public in here, okay, by default, everything of a class is private. By default, everything of a class is private, not public, but private. That's why I need to do this. This is public and this is private. Okay, good. And what else? Okay, let's wrap up this class and let's talk about this thinking objects. Previously, when we write C programs, we said that I am going to write one main function, definitely. This main function will call F1. F1 might call F2 and F4. Also, I will call F7. F7 might call F7, F4 and F11, etc. This was our structure, okay? It was our algorithm. We always think about the algorithm. We always think in terms of functions. In object-oriented programming, we don't do this. In object-oriented programming, we don't do that, okay? We say that we have classes, okay? I have a class A. Inside the class A, I have my functions, public functions, and maybe private data, okay? Private data string S. These are private. So this is, okay, this is class A and this is class B again. I do the same thing. This is how you design your object-oriented programs. You design in terms of classes. And classes is designed around their data. Data is the focus. And of course, we still have our algorithms. We have functions. But functions are supposed to work on that specific data. They are not global functions. Okay? And when I design my whole software solution, your software solution is designing your classes and designing how those classes interact with each other. And we are going to see examples of it. I mean, if you have two classes, how are they going to communicate with each other? We will see examples of it in our next lectures. Okay, good. That's it for today. Are there any questions? I think I did not give any breaks, so I was supposed to finish up with it at 12:20. So I think I made it up. Any questions? If there are no questions, then that's it for today. Tomorrow morning we will continue from this point. Read chapter 6 and 7 before coming to class, okay? Read chapter 6 and 7.